So in this video, we are going to see the solution to some exercise problems from section 3.4. This section deals with the product rule and the quotient rule. What is the product rule? The product rule says that when you're taking the derivative of a product of two functions, then you take the derivative of the first function times the second function plus the derivative of the second function times the first function. That's a product rule. And in the quotient rule, you have what is given here, which is the product of the denominator function times the derivative of the numerator minus the numerator function times the derivative of the denominator all over denominator squared. Now, for the quotient rule, the order is important. For the product rule, it's not. You can reverse the order and you'll still get the same answer. So now let's go ahead and apply this rule to the following questions. In question 9, we have a product of two functions, and I'm going to use the product rule. So the product rule says that keep the first function as is, multiplied with the derivative of the second function, plus keep the second function as is, multiplied with the derivative of the first function. Now, if you're asked to simplify this, you can distribute and combine the like terms. If that is not specified, you can leave your answer as is and you'll still get full credit. And this is the answer. You'll get the same answer had you first FOILed out the original function and then taken the derivative using the sum and difference rule. Okay. Now for this problem, I could go with the quotient rule, but wherever possible, I'm going to be a little bit smart about it. I'm going to see whether I can simplify the given expression to make my life easier. Now in this case, I can, right? Because I can rewrite my original function like so. I can split it up like so. So when I split it up like so, each term is going to get simplified. This is going to become 2s squared. This is going to become 5s. This is going to become just 3. So my original expression simplifies to this. Now taking this derivative is just the power rule and the sum and difference rule. So I do that and I get my answer in one step. I could have done the same thing here. I could have expanded this polynomial and applied the sum and difference rule. Here the question asks you to do two ways in which to differentiate this. Let's see. Method 1. In method 1, I rewrite my given expression as a power like this. 1 over x to the 10th power can be rewritten as x to the power of negative 10. And I just apply the power rule. And this becomes negative 10 x to the power of negative 11. And that can be rewritten like so, right? So this is one way of doing it. In the second method, I'm going to apply the quotient rule. So when I apply the quotient rule, what do? I bring the denominator up times the derivative of the numerator minus keep the numerator times the derivative of the denominator all over denominator squared. So x to the power of 10 times 0 is 0. So this becomes negative 10 x to the power of 9 divided by x to the power of 20, which is negative 10 over x to the power of 11. So you get the same answer in both ways. All right, the question asks you to find the slope of the tangent line to the function at two different points. Okay. So to do this, I'm going to find the derivative function first. And for that, I'm going to use the quotient rule. I take the denominator, multiply with the derivative of the numerator, minus numerator times the derivative of the denominator, all over denominator squared. Simplify this. x plus 6 minus x over x plus 6 the whole squared, which is 6 over x plus 6 the whole squared, because this and this gets cancelled. So the question is asking you to find the slope of the line tangent to this function at two different x values, right? So what is the slope of the line tangent at an x value of 3? I just substitute 3 here. 3 plus 6 is 9, squared is 81. I can simplify this to 2 over 27. Then the slope of the tangent line at an x value of -2 is 6 over -2 plus 6 is 4, 4 squared is 16, which is 3 over 8. Okay, here I have to just find the derivative. Now I can use the product rule, or I think to myself, is there a better way of doing this problem, which is probably smarter way of doing this problem? And I think that if I first distribute, that will make my life easier. So 3 times 2 is 6, x to the power of 6 minus 3x to the fourth power. Then I just apply the power rule here. So I have 36x to the fifth power minus 12x cubed, and I'm done. So again, I'm going to do the same thing. I'm going to rewrite it. Okay, I'm going to do it in both methods here so that you can see both methods. In the first method, I'm going to just rewrite it. Remember, square root of t is nothing but t to the power of 1/2, correct? So when I FOIL this, t cubed times t to the power of 1/2, I have to add 3 plus half, which is 3.5. That is 7 halves plus t cubed. So I take the derivative, I get 7 halves. T to the power of 7 halves minus 1 is 5 halves plus 3t squared. Okay, so this is what the answer I get by simply distributing and then taking the derivative. Now let's do the same thing using the product rule. Okay, so if I do the product rule, I keep the first term times the derivative of the second term plus second term times the derivative of the first term. I simplify and I get uh, 3 minus mm, okay, so 3 minus 1/2 is 2.5 or 5 halves. So I have t to the power of 5 halves over 2 plus 3t to the power of 5 halves plus 3t squared. Then I combine the half and the 3 because this coefficient is 1/2 of the first term, and then this 3. So 3 plus half is 7 halves. I get the same answer. So please make sure that you are comfortable with adding and subtracting fractions and so on. Okay. Okay. So for this problem, I am going to do this first. I'm going to rewrite this problem like so, because 2t minus 2 to the power of -1 is nothing but, so remember, this is nothing but 3t minus 1 times 1 over 2t minus 2, which can be put together as 3t minus 1 all over 2t minus 2. Then I apply the quotient rule, take the denominator up times this minus this times this all over this squared. Then distribute 60 minus 6 minus 60 plus 2 all over 2t minus 2 the whole square. So this and this going to get cancelled away, leaving me with -4 over 2t minus 2 the whole squared as my answer. Okay. Okay, next one. I rewrite it like so. Okay. So the t to the power of 7 can be rewritten as t to the power of 1 over t to the power of 7 can be rewritten as t to the power of negative 7. Then this derivative is nothing but 60 minus 42 t to the power of negative 8, and that can be rewritten like so. So it's always a good idea to leave your answer with positive exponents, right, wherever possible. And this will be your answer. Okay. So here, before I do anything, I'm going to distribute my numerator alone. Okay, actually, I can distribute. Okay, actually, you know what? I could have simplified it in the first step, but I didn't. That's okay. So I'll proceed like so. So that means I can split up the terms like this, right? So that means my original function is nothing but 3 half minus x over 2. That's all it is. So what is the derivative of 3 halves? 3 halves derivative is 0. What is the derivative of negative x over 2? Is just negative half. Because remember, negative x over 2 is nothing but negative half times x, one and the same. Okay. Okay, takes us to this problem. I'm going to use the quotient rule, so follow along, please. The first thing I do is take the denominator, move it here, times the derivative of the numerator, minus, keep the numerator, times the derivative of the denominator, all over denominator, the whole square. Distribute here this and this, root w will get cancelled, giving me 1/2 plus root w minus 1/2 root w minus w. Okay, minus, I FOIL here, I get 1/2 minus root w plus root w over 2 minus w all over root w minus w the whole square. So now let's see what can get cancelled. Before I do that, I'm going to just expand. So that you don't make any mistake with the signs here. So then I cancel, okay? The half and the half goes away. This and this goes away. So then what happens is root w minus 1/2 root w is half root w. There is another half root w. So together they just make root w. And this is my final answer. Okay. Okay. Now again, I'm going to use my quotient rule. Take the denominator up, minus 1 over 2 root r, minus keep the numerator times the denominator derivative all over this. I distribute, I will have negative r minus 1/2 root r, correct? Minus 1 minus 1 minus 1 over 2 root r minus 2 plus r plus root r all over r plus 1 this whole square. Let's see what gets cancelled here. These two gets cancelled. Okay, then I combine the like terms. This -1 and -2 together are going to become -3. And then the -1/2 or root r, plus root r can be combined to +1/2 root r minus 1/2 root r all over r plus 1 the whole square. So can leave it like this, I suppose, or you can just multiply by 2 root r throughout. So that will give you -6 root r plus r minus 1 over 2 root r times r plus 1 the whole squared. So I don't know what is expected out of you. So here I just multiplied by 2 root r throughout, that's all. So that will be your final answer, or the previous step could be okay. So depending upon how you are supposed to enter the answer on the platform that you use. Okay. So the second, in this question, you're given a function and you're asked to find the equation of the tangent line to the curve at x equals 3. So let's do that first. To do that, I need to find the derivative first. I use the quotient rule. This is what I have. I distribute and simplify. And this is what I have. So now I'm supposed to find the slope of the tangent line at x equals 3. To do so, I just substitute 3, right? Yes. 3 minus 1 is 2. 2 squared, 2 squared is 4. So I have -6 over 4 is -3/2. So now to find the equation, I need to do y minus y1. So when x is equal to 3, what is y1? 3 plus 5 is 8. 3 minus 1 is 2, so that is 4. So we have 4 here. So y minus 4 is -3/2 x minus 3. So this is -3/2 x plus 9/2. Then I add 4 to both sides. 4 is 8 over 2, correct? So 8 plus 9 is 17. And that's the answer. Okay. Okay, so here we first find the first order derivative, but before we do anything, I'm going to distribute. So 2x squared plus x to the power of -1, okay? Then first order derivative is 4x minus 1x to the power of -2, which can be written as 4x minus 1 over x squared. So second order derivative will be 4 minus 1 times -2 is positive 2 over x cubed, right? Or in other words, let me write it like this. X to the power of -3, which can be written as 4 plus 2 over x cubed, okay? And then for the third order derivative, this will go away. So we'll have -6x to the power of -4, which can be written as -6 over x to the fourth power. Okay. All right. Now here, the first and the second order derivative, we have to use the quotient rule. So quotient rule, x plus 1, 2x minus 7 minus x squared minus 7x times 1 all over x plus 1 the whole squared. I FOIL here. I have 2x squared minus 7x plus 2x minus 7 minus x squared plus 7x all over x plus 1 the whole squared. So let's see what gets cancelled. This and this goes away. So I'm left with x squared plus 2x minus 7. Okay, so this is my first order derivative. Now, you don't know the chain rule or anything yet. So what I'm going to do is I'm going to expand my denominator. So I usually never expand my denominator, except in this case I'm doing because I need to find the second order derivative. Okay. So then I take this denominator up, numerator minus numerator times derivative of the denominator all over denominator the whole squared. Okay, so then I can see what gets cancelled, but then before that I need to distribute and all of that stuff. So let's do that. So I have, oh my god, this is too much, right? Wait a minute. 2x plus 2 is a common factor. So that means I can take it out. So x squared plus 2x plus 1 minus, okay, so this is becomes plus 7, so this will become 8. So this will be my final answer when I distribute, combine the like terms and all of that stuff. So you can do all of that, just expand the first product minus the second product and see what happens. And I'm guessing this is what will happen, okay? All right, in this problem, a table of values is given and they're asking you to find the product of f and g at x equals 1. Now remember, what does the product rule say? The derivative of this product is nothing but f of x times g prime plus g of x times f prime, right? Now you have to evaluate it all at x equals 1. So what is so all of this at x equals 1. So what is f of 1? F of 1 is 5. What is g prime of 1? G prime of 1 is 2. Plus, what is g of 1? 4. What is f prime of 1? 3. And when you combine all of this, you will have 10 plus 12 is 22. Now we need to do this for quotient rule for x equals at x equals 2. So g of x times f prime minus f of x times g prime all over g of x the whole square, and we had to do it all at x equals 2. So what is g of 2? G of 2 is 2. F prime of 2 is 5. Minus f of 2 is 4. G prime of 2 is 4 divided by g of x the whole squared. So g of 2 is 2, 2 squared. Simplify this. 10 minus 16 is negative 6 over 4 is negative 3 halves.